section of this 5-piece, we dealt with exponents, then we dealt with adding and subtracting monomials, and they had to be like terms. Then we dealt with multiplying monomials, then dividing monomials, and now we are going to move towards the powers of monomials. So what do we mean by powers of monomials? Well, if we have 2 to the second to the third, that would be a power of a power. Power to a power. And so we know certain things. We know that when you have 2 to the second times 2 to the third, when we multiply like bases, what do we do with their exponents? We add them. When we divide like bases, when you have 2 to the fifth over 2 to the second, when we have like bases and we are dividing, we subtract those exponents. And now when we have a power of a power, think about that. That's 2 to the second. That's the base of this exponent. The base of the power of 3 is 2 to the second. So we would have that 3 times, right? 2 to the second, 3 times itself. Well, this is 2 times 2, and this is 2 times 2, and this is 2 times 2. So how many? We have 3 sets of 2 times 2's. So that's going to be 2 to the sixth. So when we have a power of a power, we are going to multiply those exponents to get 2 to the sixth. So we have x to the fourth to the eighth. That equals x to the 4 times 8, or x to the 32nd. Well, I don't know where I got 12 from. All right, so very important. And the other next thing is, all right, if we have that, what if we have x to the second, y to the third to the second? Well, that means we have 2 of these bases. That means that we would have 2. So you are going to distribute this exponent into each term. This is the only time you can distribute across multiplication, because we're multiplying those two. So this becomes x to the second times 2, y to the third times 2. You notice that we distributed that 2 into each of the terms, x to the second and y to the third. So my answer is going to be x to the fourth, y to the sixth. Very, very tricky. So what if I have a constant? What if I have 2a to the third, b to the fourth to the third power? So remember that 2 is to what power? There's an invisible 1 there. So when I distribute this 3 into the parentheses, I have to distribute it to all 3 pieces. So that's going to become 2 to the 1 times 3, a to the 3 times 3, and b to the 4 times 3. We see, what are we distributing? We're distributing that 3. So that's why we have the 3. And we're distributing it to a 1. Whoa, that did not work well. We're distributing it to the 1, the 3, and the 4. So my answer is going to be, well, my next step is going to be 2 to the third, a to the ninth, b to the 12th. Well, 2 to the third we can simplify. We can always simplify constants. 2 times 2 times 2 is 8, a to the ninth, b to the 12th. So whenever you have constants, you're going to simplify that. Let's try one more. Let's do 3, x to the fourth, y to the negative 2 to the negative 3. What? Craziness. We're going to distribute this negative 3 to each piece. So this is 3 to the 1 times negative 3, x to the 4 times negative 3, and y to the negative 2 times negative 3. So that becomes 3 to the negative third, x to the negative 12th, y to the positive 6. We have to deal with these negative exponents. We got to get rid of that negative. So that's going to become 1 over 3 to the third. That goes from the numerator down into the denominator. We got to deal with this negative exponent. So that goes down with it, x to the 12th. And my y to the 6th stays in the numerator. So y to the 6th, 3 to the third. That's 3 times 3 times 3, which is 9 times 3, which is 27 x to the 12th. We can't combine y's and x's because those are unlike bases. So my answer is y to the 6 over 27 x to the 12th. Let's try some. Okay, we have x to the 4th to the 2nd. We have a power of a power. So that becomes x to the 4 times 2, or x to the 8th. We have a to the 3rd to the 2nd, a to the 3 times 2, or a to the 6th. This is our first multi-thing. We have a constant and a variable in the parentheses, so we have to distribute that power of 3 into both of those. So that's 6 to the 1 times 3, n to the 1 times 3, 6 to the 3rd, n to the 3rd. 6 to the 3rd is 6 times 6 times 6, which is 36 times 6, which is 3 times 6 is 18 plus 3 is 21, 216, 216 n to the 3rd. Woo. We talked about being able to multiply numbers. You should know those. Oh, we're going even bigger. Here we go. We have the 4 distributes to the 3, and the 4 gets distributed to the x to the 3rd. So that's 3 to the 1 times 4, x to the 3 times 4, 3 to the 4th, x to the 12th, 3 to the 4th, 3 times 3 times 3 times 3. 3 times 3 is 9. 9 times 9 is 81, x to the 12th. Oh, I like that. Let's distribute that. 3 to the 1 times 4, n to the 4 times 4, 3 to the 4th, n to the 16th. That's 81 n to the 16th. Whoa, look at this. Look at that coefficient. Coefficient is negative 2. The other variable is x, and we have to distribute that 4. We have to be careful about how we write this. So I have to write negative 2 with parentheses because that negative has to be attached to the 2. And that's to the 1 times 4, x to the 1 times 4. So we have negative 2 to the 4th, x to the 4th. Negative 2 to the 4th is negative 2 times negative 2 times negative 2 times negative 2. That gives me 4 times 4, so that's 16 x to the 4th. Good problem. Here we have that negative again. So we're going to have negative 4 to the 1 times 4, m to the 3 times 4. That's negative 4 to the 4th, m to the 12th. Sounds like Morse code. That's 16 times 16. I don't know what 16 times 16, so I take out my handy dandy notebook. Right. 16 times 16, 256. M to the 12th. And since there were an even number of negatives that I was multiplying, I knew my answer had to be positive also. All right, this one's a nice, easy one. K to the 4 times 2, which is k to the 8th. Going back to that negatives, that's 1 times 3, x to the 4 times 3. That's negative 5 to the 3rd, x to the 12th. Negative 5 times negative 5 times negative 5. I have 3 negatives, so I know my answer is going to be negative. but I could just do it out. And I get negative 125x to the 12th. 3r to the 4th, 3 to the 1 times 4, r to the 1 times 4, 3 to the 4th, r to the 4th, or 81 r to the 4th. Negative 7 to the 1 times 2, n to the 3 times 2, that's 49 n to the 6th. Negative 2 to the 1 times 2, x to the 1 times 2, that's going to give me negative 2 to the 2nd, x to the 2nd, which gives me 4x squared. 5 to the 1 times 3, x to the 1 times 3. 5 to the 3rd, x to the 3rd. 5 to the 3rd at this point, I should remember, is 125. Negative 6 to the 1 times 2, n to the 2 times 2. Negative 6, quantity negative 6 squared, n to the 4th, which would give me 36 n to the 4th. Oh, to the 0. We almost forgot about that. So this is going to be negative 4 to the 1 times 0, x to the 4 times 0. Well, 1 times 0, negative 4 to the 0, x to the 0. Negative 4 to the 0 is equal to 1. X to the 0 is equal to 1. So my answer is going to be 1. Very, very interesting question. It'll be interesting to see how many of you get that right or wrong. That is going to be great. Remember, anything to the 0 power. 8 to the 0 is equal to 1. X to the 0 is equal to 1. Negative 2 to the 0 is equal to 1. A million to the 0 is equal to 1. Trick question, because it's trick or treat, because it's October. What is negative 4 to the 0? Negative 1. Why? Here's your exponent. What's the base of that exponent? So that equals 1, and then we have the negative that is outside of it, the negative 1. Trick question. No parentheses, so there's a big difference there. With the parentheses here, the base of this exponent is negative 2. That's a good one. We have 8 to the 1 whole times negative 2. Now we're getting into negative exponents. Negative 4 times negative 2. That's 8 to the negative 2. And negative 4 times negative 2 is positive 8. We got to get rid of this negative exponent. So it moves down into the denominator. And now we can simplify that. That's n to the 8th over 64. Good question. Negative 4 to the 1 times 2, x to the 4 times 2. Negative 4 to the 2nd, x to the 8th. 16 x to the 8th. Don't confuse negative coefficients with negative exponents. Don't move that negative 4 down into the denominator to make it positive. It's not an exponent. We only move things numerator and denominator when we're dealing with exponents. Common mistake that I see students make. That's negative 2 to the 3rd, x to the 12th. Negative 2 to the 3rd is negative 8, x to the 12th. Do not move it into the numerator and denominator. It's just a negative coefficient, not a negative exponent. Whoa, look at 20. We got negative coefficients, negative exponents. So we have negative 3 to the 1 times 2 and a to the negative 1 times 2. So that gives me negative 3 to the 2nd, a to the negative 2. Oh, this is really good. Separating. Negative 3 to the 2nd is 9, a to the negative 2. And now we got to get rid of that negative exponent. So 9 stays on the top because it's not connected to the base of that exponent. A to the 2nd, 9 over a to the 2nd. Some really good questions here at the tail end. Oh my goodness, now we got more to the zeros with negatives. U to the negative 1 times 0, V to the 4 times 0. That becomes U to the 0, V to the 0. That becomes 1 times 1, or 1. Negative 3 to the 1 times 3, x to the 2 times 3, y to the 4 times 3. Negative 3 to the 3rd, x to the 6th, y to the 12th. Negative 3 to the 3rd is negative 27, x to the 6th, y to the 12th. We know that any negative number to an odd power will stay negative. 7 to the 1 times negative 1, a to the 4 times negative 1, b to the negative 3 times negative 1, 7 to the negative 1, a to the negative 4, b to positive 3. Let's deal with those negative exponents. Those will go down. So b to the 3rd stays in the numerator, 7a to the 4th. 3 to the 1 times negative 4, x to the 1 times negative 4, y to the 3 times negative 4, 3 to the negative 4, x to the negative 4, y to the negative 12. Let's deal with those negative exponents. Change the locations. So there's nothing left on the top, so we would represent it with a 1. That's 3 to the 4th, x to the 4th, y to the 12th. So it becomes 1 over 81, x to the 4th, y to the 12th. Oh, you guys are going to be ready for high school math. You get all this, you are doing just fine. 2 to the 1 times 4, x to the 0 times 4, 2 to the 4th, x to the 0, 2 to the 4th equals 16, x to the 0 equals 1, so my answer is 16. Good problem. Good luck with the homework. That is some good stuff.